And for this one, we have a manufacturing plant earned $80 per man hour of labor when it opened. Each year, the plant earns an additional 5% per man hour. So we need to write a function that gives the amount, A of t, that the plant earns per man hour, t years after it opens. So let's first define our variables. We have t, that's going to be time again, and our unit, once again, will be years. And we have A of t. So that is the amount that the plant earns per man hour. So we can call that our total amount, or just our amount. Now, once you understand the variables, now we can go back and try and figure out key information. So the plant earned $80 per man hour of labor when it opened. And each year, the plant earns an additional 5% per man hour. So this is our starting amount, that's $80 per man hour of labor. And this 5%, this is our growth rate. This is how much it's increasing every year. So let's write down that information. We know when time is 0. So if we plug in t equals 0 into our formula, the amount would be $80. Since the unit for our amount, this is money per, or divided by, man hour of labor. So it's a little bit confusing with the unit here, but it's money per man hour of labor. And when t is equal to 0, we know that we have $80 per man hour of labor that the plant is actually earning. So we also know that each year the plant earns an additional 5% per man hour. So we can write that down as well. And that is our growth rate. So we can write growth rate is an increase of 5% each year. So that means we have the original amount. The full amount is just 100%, and then we're adding 5% on top of that. And you need this 100%, because if you just look at 5%, or if you just multiply by 5% every year, then the amount will get very small very quickly. So you need that original 100% because we're going to be adding on top of that. And if we rewrite these as decimals, we know 100%, that's just 1. And this is 5 divided by 100, so 5 hundredths, which is 0.05. So adding these together, we get a growth rate of 1.05. So in other words, every year we will multiply by 1.05. And now that we know the starting amount and the growth rate, we can compare those to our general formula. So remember, when we have f of t, some exponential function, that this is equal to the starting amount, which we can call a, multiplied by the growth rate, or the decay rate in some cases, raised to the t power. So just quickly, a, that's our starting amount, and b is our growth rate. And of course, t just represents time in all of these problems. So comparing it to our general formula, we can rewrite our function, a of t, as being equal to the starting amount, 80, multiplied by that growth rate, 1.05, and that's all raised to the t power. So this right here will be our final answer for our formula. Though to check these, I encourage you make a table and make sense of this formula for yourself. But essentially, when t is equal to 0, this 1.05 to the 0 power, that's just 1, and 1 times 80 is 80. So for that starting amount, 0, this formula makes sense. And then when t is 1, we're multiplying by 1.05 one time, which does make sense since every year we're going to multiply by that 1.05. That's just the percent, the 5% that we're increasing every year. So for year 2, we multiply by it twice. For year 3, we do it 3 times, and so on. But to really make sense of this, again, you want to make a table just to see the pattern for yourself.